In this video, we're now going to define a derivative. So the derivative of a function f is that function denoted by f prime such that its value at the number x in the domain of f is given by the following. F prime of x is equal to the limit of f of x plus delta x minus f of x over delta x plus delta x approaches 0 provided this limit exists. Take note that the derivative of a function s is also a function. So the limit that we have looked in the previous video is defined to be a derivative. So to find the slope later on is the same as finding the derivative. Note that the process of finding the derivative of functions is called differentiation. So a function is differentiable. A function is differentiable at x if its derivative exists at x and is differentiable on the open interval a and b. If it's differentiable at every point in the interval. So we have different notations for our limit. We have using prime, so that's f prime of x or y prime. We have dy over dx. We also have this and so on. So we can use different notations to define our derivative. It's just that using the limit process in finding the derivative is quite tedious. Hence, we have different rules so that we can go away with the limit process. So we have the derivative of a constant. The derivative of a constant is 0. So whatever constant that may be, its derivative would be 0. One of the most useful rules is the power rule, wherein if f of x is equal to x raised to n, its derivative is n raised to x minus 1. We then have the constant multiple rule, saying that if a constant is multiplied to a function, and that's one entire function already, its derivative is just you factor out the constant multiple and then find the derivative of the function. So for sum and difference rule, the derivative of a sum function is the sum of the derivatives of the two given. Sorry about that. And then we now have one of the two rules that we have to be mindful of. First is the product rule. If a function is composed of two functions that are multiplied to each other, then its derivative would be the original of the first times the derivative of the second plus the derivative of the first times the original of the second. We have to be mindful of that pattern for our product rule. On the other hand, we have our quotient rule that says the derivative of if a function is a quotient of two other functions, then its derivative is this. I would usually use the mnemonic by assigning this as high and this is low. So let's use the colors. So let's say this is high and this is low. So I'm going to have to memorize or to be more familiar with this. I've used the mnemonic low, derivative of high minus high, derivative of low over low square. Low d high minus high d low over low square. For us to easily remember the quotient rule. Again, that's a mnemonic that I use for the quotient rule. Low d high minus high d low over low square. Alright, so let's apply those differentiation rules here. Mostly, as you might have noticed, those are for algebraic functions. So I will not answer all, we'll just answer some. The rest will be left for you. So for the first one, we have y equals 6. So as we are told, it's the derivative of a constant would always be 0. Since 6 is the function, so the derivative of 6 is 0. For the second one, we apply our power rule that the derivative of this would be you bring down the exponent, that's 8, then the variable x, then the exponent becomes 8 minus 1. This leads us to that y prime is equal to 8x raised to 7. So for the constant multiple rule, like we mentioned, what we can do is that we just keep up the constant and then we find the derivative of this. And the derivative of x cubed using the power rule is 3x squared, which gives us our final derivative. Y prime is equal to negative 57, negative 57x squared. So number 4 is a combination for sum and product. This is sum and then, sorry, it's not a sum product, sum and difference. So all we need to do is find the derivative per term and then combine them together. So y prime will then equal to, this becomes 9 times 4x cubed, following the constant multiple rule and the product rule here, plus another constant multiple rule and then product rule, that's 16 times 2x minus the derivative of 5, which is 0. This then leads us to y prime is equal to 36x cubed plus 32x. So this becomes the derivative. Now for number 5, you may want to first multiply those two and then just do what we do in number 4. But you can also apply our product rule here, that in number 4, f prime of x here will then become the original 3x squared minus 4. That's the derivative of the first, which is 3x squared. Then plus the derivative of the first one, which is actually 6x times the original second, x cubed minus 7. So combining this, we're going to have, that becomes 9x to the 4th minus 12x squared. Then I have plus 6x to the 4th minus 7x. So combining like terms, I'm going to have 15x to the 4th minus 12x squared minus 7x. This is the derivative at number 5. So for number 6, let me fix it here. Okay, so for number 6, we have f of x is equal to 2x plus t over 2x minus 2. What will be the derivative of this function? If you remember, for quotient rule, we have low derivative of high minus high derivative of low over low squared. So in this case, we're going f prime of x will then equal to low, that's 3x minus 2, times the derivative of high. In this case, it becomes 2 only. Because if we're going to apply the constant multiple here, 2x, that becomes 2 times 1x raised to 0, which becomes just simply 2, just becomes 2 times 1, it's 2 here, minus high 2x plus 2 derivative of low. So in this case, 3 all over low. Then we just have to simplify and see what we're going to do from here. So what we're going to have here would be, that's 3 times 2, 6x minus 4. This is negative, and then this will have negative 3, so that becomes negative 6x minus 9 all over 3x minus 2 squared. Since this is 6x and negative 6x, that gets cancelled out. And negative 4 minus 9 becomes negative 18. And since this is just square, we can easily expand this. Therefore, the derivative of number 6 will become negative 13 over 9x squared minus 12x plus 4. So the rest of the items in this slide, you can use them for practice and finding the derivative. Now, one special rule in defining the derivative in differentiation is the general power rule, which comes from the chain rule or the derivative of a composite function. The derivative of a composite function says that when you're going to find the derivative of a composite, you find the derivative of the outside, then multiply the derivative of the inside. This is generally what the general power rule says. You first do the derivative outside, then you find the derivative of inside, then multiply to it. For example, in number 1, although it doesn't look like it's a general power rule, you can just use quotient here. Remember that by loss of exponents, this is equivalent to y is equal to x plus 1 raised to negative 1. So applying the general power rule, y prime then will be equal to x negative 1 times x plus 1 raised to negative 1 minus 1 times the derivative of x, which is well certainly 1. So therefore, we're going to have negative 1 x plus 1 raised to negative 2. With that, therefore, the final first derivative of the function would be negative 1 over x plus 1. Sorry. Over x plus 1. Same thing can be done in number 2. So for number 2, we're looking for the derivative of the function f of x is equal to 3x squared minus x plus 1. As we know, square root is the same as 3x squared minus x plus 1 raised to 1 half. So following our rules of differentiation, f prime of x will be equal to 1 half times 3x squared minus x plus 1 raised to 1 minus 1 half, which is 1 half as well, times the derivative of the 1 inside, and that's actually 6x minus 1. Sorry, I think this should be negative 1 half, because it's 1 half minus 1. So therefore, what we're going to have here, when we write it without a negative exponent, it becomes 6x minus 1 all over 2 times, I'm going to still use the 1 half here, 3x squared minus x plus 1 raised to 1 half. Just saying that we have an irrational in the denominator. So what we need to do is to multiply both the numerator and the denominator by 3x squared minus x plus 1 raised to 1 half. X squared minus x plus 1 raised to 1 half. So therefore, this gets cancelled, and what we're going to have here would be 6x minus 1 times 3x squared minus x plus 1 raised to 1 half all over 2 times 3x squared minus x plus 1. Finally, writing the final answer, the first derivative or the derivative of this function becomes 6x minus 1 times, you can write it squared, you can write it raised to 1 half. I better write it with square root of 3x squared minus x plus 1. Go all over 6x squared minus 6x plus 2. Distributing the 2 on the denominator. So there, that's your first derivative in number 2, applying the general and power rule. So the rest of the items here can be left for you for your practice. Now, how do we use those rules in finding the equation of the tangent and the normal line? Let's do that for number there you go. There is something where this number is spent. So let's go to it for number 1, 8. Okay. Alright, so for 1a we have y is equal to x cubed minus 4 one will be the equation of the tangent line and the normal line at the point 2, 4. So remember, we are told that the slope of the tangent line is equal to the limit of f of x plus delta x minus f of x as delta x over delta x rather as delta x approaches 0, which according to the definition of derivative is actually the derivative of the function. So that's what we need to find instead of looking for the limit. Hence, y prime will then equal to, that's x cubed, so we're going to have dx squared. 4 is a constant, so its derivative is 0. No need to place. So from here, we can now find the slope of the tangent line at the point 2, 4, which would then be 3 times 2 times 2 squared. So that ends us up with 3 times 4, which is equal to 12. So therefore, the slope of the tangent line would be equal to 12. And at the point 2, 4. Therefore, finding this equation of the tangent line, we have y minus 4 is equal to 12 times 2. So now we need to just distribute this first. We're going to have y minus 4 is equal to 12x minus 22. Variable. So therefore, find y prime will be equal to 12x minus 20. Alright, so go again. That would be the equation of the tangent line. But for the equation of the normal line, the equation here, for the slope of the normal line, it should be the negative reciprocal of the slope of the tangent line. With that means what I'm going to get will be negative 1 over 12. That's the basic. That's the time we now substitute the slope of the tangent line. So now that we have the slope of negative 1, 12 and at the point 2, 4, we can now find the equation of the normal line. So therefore, we're going to have y is equal to, y minus 4 is equal to negative 1 over 12 plus 2. So, rewriting that in slope inverse form by first looking into the slope and multiplying it to the to this one here. So we'll just note to have y minus 4 is equal to negative 1 over 12x minus plus 1/6. There you go. So from there, we transpose this and we're going to have y is equal to negative 1 over 12x plus 1/6 plus 8. That would now be 1/6 plus 4. So the equation of the normal line is that y is equal to negative 1 over 12x plus 25/6. And that's an example of how we use the differentiation rules to find the slope of the tangent and the normal line, and then later on the equation of the tangent and the normal line. So the rest of the items will be for you to solve on your